Build the best with active tests. Shift left with API security, leveraging no-name machine learning technologies. They've got no-name active testing API security scan tools integrated with Azure DevOps, CI/CD build pipelines, as well as GitHub for continuous automated red teaming, also known as CART. There's a link at the bottom of the slide there to direct you to some documentation on our new version of active testing that we've recently released. A little bit about me. I'm Ryan B., a technical director with No-Name. Been here almost 2 years now, and I'm focused on strategic machine learning API security solution architectures. I used to be a CISO at a cloud startup called Joyent, who invented Node.js. Was also with IBM, focused on grid computing, and I've done independent consulting, as well as focused on startups, specifically in API gateway spaces like Apogee and Akana. I think API security requires machine learning because it is a superhuman problem to solve. Enterprises have thousands of APIs in production, and over 60% of enterprises say they've experienced a breach in the past year. The issue here is that it takes over a month to resolve these incidents, 27 days to discover what happened, another 10 days to remediate each incident. What No-Name is doing is we categorize API risks according to the OWASP top 10 API security risks, from broken object level authorization, meaning that user A is able to do something that only user B is able to do, broken user authentication, perhaps where an anonymous user is able to do something that an admin's only supposed to be able to do, excessive data exposure issues, where we've got things like credit card numbers or socials in clear text that simply shouldn't be, lack of resources and rate limiting, where the gateway simply isn't throttling the transaction volume as it should be. Broken function level authorizations are where a user is able to delete or put or post something when they're only supposed to be able to get something. Mass assignment is where brute force attempts to insert malicious parameters into API requests are sent right through the API gateway, or perhaps there isn't an API gateway involved that's even able to detect that that's happening. Security misconfigurations are quite common as well, where enterprises are investing in very expensive WAFs and API gateway technologies. However, they're simply misconfigured. Then there's what happens on the outside. Users could be malicious, bots could be malicious, and they could send malicious code injections to your endpoints, things like SQL injections or JavaScript injections. Improper asset management is where the Swagger spec or the Open API spec is simply misconfigured in such a way that what's happening on the wire doesn't match up with what's documented in the API design. And then there's the simple problem of insufficient logging and monitoring. There are API security risks at the edge of the cloud, as well as in the core of the service mesh. So we have to mitigate these things at the layer where the WAF is and the API gateway is, as well as behind that in the VPC. What we're doing here with active testing is we have configured a static environment where we have an API hosted on an Azure Linux VM out there on the cloud. And we're going to simulate an attacker sending malicious requests to that API server where it has no API gateway in front of it at all. We then have the ability to change this configuration in No-Name active testing to route traffic through an Azure API manager to watch the difference in how those security risks are then mitigated by adding that additional layer of security policy enforcement on the edge of the network. The solution is pretty much designed to look like this. We're sending traffic from our active testing server through that API gateway, the Azure APM, and then it's then routed from the Azure APM to a virtual machine in Azure that is then responding with the JSON message. We are also then sending data directly to that Azure virtual machine without an API gateway in front of it and watching the difference in those security results. Meanwhile, we have a sensor on that virtual machine that is watching what's happening on the virtual machine and sending that data to the No-Name machine learning engine, as well as we've integrated with the Azure diagnostic logging feature of an Azure API manager, and we're also watching what's happening on the Azure API manager as these tests are occurring, and that data is also being analyzed by the No-Name machine learning engine as well. We also have GitHub integrated here, and all of our configuration files are persisted in GitHub. And the JFrog repository shown at the top right is where Azure DevOps is downloading from JFrog. It's pretty much a Docker Hub equivalent. Our CLI scanner to run inside Azure whenever a change is made to the artifacts in GitHub. The end solution looks something like this, where what we mean by shift left is active testing is shown there on the left-hand side during that build phase, as opposed to in the center of the chart here where you see the word test as part of Azure test plans. We're not leveraging any Azure test plans. We're simply leveraging the native features of an Azure DevOps CI/CD build pipeline. And then on the right-hand side, in the runtime configure and operate section, we've got the Noname machine learning engine analyzing the real-time traffic as it's occurring on the wire. The result is continuous testing, also known as continuous automated red teaming. Let's take a look at the live demo now and see this in action. Here's my GitHub environment where I've got a number of artifacts configured here. I've got my Azure pipeline, so any change I make in my Azure pipeline is automatically persisted here to my GitHub repository. And as you see here, I switch over to my Azure DevOps environment. I recently ran a scan on the unprotected API directly. And as you can see here, as it did the scan, it found a number of high, medium, and low issues. You'll see some are passing and some are failing. I've got the threshold of my active testing environment configured to medium. So you'll see here that if I have scans that are failing that have a threshold or severity of medium or high, then what we are doing is preventing this deploy API step from occurring. And so I could lower that to none and say, well, just go ahead and deploy the API even if scans are failing. But the whole point of leveraging this tool is that when I go into my Azure DevOps environment, or even if I go into GitHub and I make a change to one of my files here. So for example, I've got this Azure APIM configuration. If I modified this right now and click the edit button, the whole point is that you want to scan that change. And right now I've got it configured with an incorrect key. And that's done on purpose. But if I change that to be the correct key, I would want to see what happens when a scan occurs with the correct credentials. And the whole point here is to first test the API without any API gateway in front of it, as I've just done. And so you see here we have a lot of tests that are failing. And if I go back to other builds or other builds that I've run, you'll see here I've also got some that have passed with a green. And this is where I have it configured. I modified the Azure pipeline to point to the active APIM config instead of just the one that's not using the APIM. And so with the APIM configured, you'll see here if I look at the scan results here when that ran, you'll see that all tests have passed because it had invalid credentials. It couldn't even connect. Noname was watching what was happening here. So you'll see here I've got two different integration sources here in my Noname machine learning environment hosted out here on our SaaS. As you can see here, I've got one dedicated for this build conference. And so it's called Build Noname Sec. And I've got two traffic sources integrated. One, I've got the sensor running on that virtual machine that's hosting the Docker container with the API server on it known as HTTP bin. And the other, I've got log integration with diagnostic logging, Noname's reading from a storage account on Azure, watching, as you can see here, that just happened 28 seconds ago because we're sending traffic directly to that virtual machine. But 10 minutes ago, I ran a scan, or 8 minutes ago, you can see there, it read from the log files when I sent the traffic through the Azure APIM. So let's take a look at my build configuration in Azure to see what I've done here to make this real. You'll see here in my edit of this Azure pipeline, I've got a number of things declared. I've got this Noname scanner job, which is the first job that I want to run. And the second job that I want to run is deploy API. And as you can see here, it depends on the success of this scanner. So if this doesn't complete, then we will not deploy the API is the entire idea. And I mentioned that we're going to download from JFrog our CLI scanner. So that's the first step in the process. Then I've got a number of variables defined here. And you'll see here, if I click on the variables button, I've got my threshold set to medium. And that's the breaking point. I could set this to none and say never break it and always deploy. So let's go ahead and make that change. Now, what am I going to scan next? I've got it configured here, my active config file. I'm going to scan here this active APIM config. That means I want the traffic to run through the Azure API Manager and not go to the VM directly. However, this time, I'm not going to prevent the deployment of the API, even if test cases are failing. But what I'm going to do first is I'm going to trigger this scan, not from the UI, and I could trigger it from the UI, I could go over here to the Noname UI and click the scan button as I've just done before, pointing directly to that VM without any API gateway in front of it, or with one. This is, as you can see here, I've got default, which is no API gateway in front of it. And I've got another environment here that has an API gateway in front of it. And I've got this main branch here, and these are the ones that are automatically scanned by the Azure build pipeline integration without any scan button being pressed at all. These are the ones that are automatically happening. As you can see here, the past two scans, there were 0 vulnerabilities found, because it was unreachable, because it had invalid credentials. And that's the way API gateways are supposed to work. Your API is supposed to be completely invisible when there are no credentials that are valid. And that's the result here when we did those other scans. Now, this time, we're going to make a change. We're going to give it the correct key. So I've got this in edit mode, and I'm going to just take this little comment out here where I have incorrect key. I'm now going to make this the correct key. I'm going to commit this change. And now, just by committing this change, you're going to see that Azure DevOps pipelines are going to wake up. Back to our pipelines. You'll see here, it picked up that change. Notice that I've made an update. And so you'll see here now there's an action occurring and it's running. I didn't click anything at all. This is an automated event just because I have got integration between Azure DevOps and GitHub configured correctly. So it automatically starts the scan. It pulls down from JFrog the scanner. So you'll see the pull is in process. And let's just watch this happen. So now remember, what we're doing now is we're sending the traffic through an Azure APM. The previous scans had the incorrect key, and so it couldn't connect, and it found 0 issues. Now I've given it valid credentials, and it should be able to authenticate with that header and key correctly. And let's watch the results in real time. And so you'll see here, we're going to get results here in both places. You'll see the results of every test occurring here in the Azure DevOps environment, as well as they'll be persisted in the Noname user interface. And all the results are also downloadable from Noname via the Noname management API, should we need to integrate with another system at some point. So now we see the scan is beginning. Takes about a minute, by the way, to download and instantiate that VM. And so now once it's instantiated the virtual machine, and it has that Docker container with the CLI running, the scans occur very quickly. So it took about a minute to instantiate, and now the scan is in process. It's probably going to take another 60 seconds, maybe 2 minutes to complete. And we can also watch what's happening in the Noname user interface as it's going through. So as you can see here, it's able to connect, and it's able to find every single path here. Failed, passed. It got properly to the post endpoint, as you can see here. And it didn't have improper error handling was that test, and so that one's a pass. If I switch over to the Noname user interface, you'll see the scan is active. And so we can see our results in both places. So as you can see there, this time it's not unreachable, and we've already found 2 broken function level authorization issues, 15 security misconfigurations, 13 broken user authentication issues, and 3 issues with improper asset management where the Swagger spec doesn't match up with what's happening on the API server itself. Go back over here to our Azure build environment, see how that's doing. Probably timing out on a few final URLs that simply are not there in that configuration, and that's okay, because I have the Azure APM configured to not expose every endpoint. And that's one of the values of an API gateway is you can hide some of these path endpoints. And so the timeout might simply be the result of the endpoint not being on the Azure API Manager, but being on the VM directly, and that's okay. So as that's finishing up, let's just watch what's happening. Let's go back over here to my slides here, and we'll take a look at the next step in the process here with regards to what we're actually bringing to market here. We're bringing to market a new model for API security, where what we mean by shift left is we're trying to bridge that gap between a development team that's building a mobile app or building a web app and the other development team that's building the API server itself. And the security team that's part of the DevSecOps organization works for the CISO or the CIO or whoever. And we're trying to just get all these teams, the platform owners, working together on the exact same schedule. So we're not waiting for weeks and months to hire pen testers and use some proprietary tools that have nothing to do with APIs anyway. Some of these scan tools that are out there don't even get to this level of detail. And what Noname is bringing to the table are API security specific test cases that are configured in such a way where it's aware of the Azure APM, it's aware of the Swagger spec, it's aware of every single get, post, put, delete verb in every URL that's part of that API specification. So we want to help these teams do business together better. Shifting left means we shift that testing earlier in the timeline. We're helping these teams protect these APIs from attacks on the wild. We're increasing the ease of integration, and we're getting it to a level of sustained hygiene with regards to your posture management and your CISO and your executive team's ability to be informed of the risks as changes are being made. So you saw the change I made in GitHub. What if the attacker knows the key of the APM? What are the risks involved when the key is known? Well, let's go back to the results and we'll take a look here. If the keys are known, the risks are spelled right out for you. So you will see here the run is complete. We finalize the job. And we see here, it's just finishing up here, tabulating the results. As this thing is finished up, you'll have something that you can present to your executive team. You can even download it as a report and email it to them should they not wish to even log on to the user interface. They don't have to. Noname's platform looks like this. We have just demonstrated active testing integration with existing investments like Azure DevOps and GitHub. We also bring to the table API posture management to point out the issues that are still in your Azure infrastructure. Even though you've made the investment to purchase an Azure API manager, there might still be configuration issues that need to be resolved. And then we're also giving you machine learning to help you find those runtime issues in production in near real-time speeds. I'm going to wrap this up with a reminder that everything that you've seen here is marketed and available for purchase directly on the Microsoft commercial marketplaces. Specifically, you'll see 2 links at the bottom of the screen. And to find out how to leverage Noname machine learning to improve your Azure API security posture and how to integrate Noname threat intelligence with your Sentinel workspace, perhaps visit these listings in the Azure marketplace. You'll see here, I've got them already pulled up here on my browser. The Noname security platform is marketed and advertised here. You can click the Get It Now button and start the process if you don't already have Noname in your enterprise. And should you have a Sentinel environment and you're interested to start the process to integrate these threat intelligence alerts from Noname, for example, if we look at the Noname security dashboard here, you'll get a summary of everything we're finding organized on those top 10 issues. You'll get this list of issues that we're finding. And should you want these issues sent directly over to Sentinel, you can integrate with a workflow. You can literally go into the Noname user interface and click on integrations and go to integrations and workflow. And this Sentinel integration that we're talking about is one of our newest integrations here. You'll see here on the bottom right-hand side, Sentinel. And so we can send our integrations, we can send our information, our threat intelligence to multiple places, to Slack channels, to Jira tickets, to ServiceNow, to Syslog, to Splunk, CloudWatch. And if you are Azure specific, we have Sentinel integration that's literally purchasable, as you can see here right in the UI. I hope you've enjoyed this demonstration. We look forward to doing business with you. Thank you very much for your time. Enjoy the conference.